Alright, so here we are with the 8-4 notes for geometry. We're going to solve some problems involving angles of elevation and depression, which of course are going to then use trig. So here we go. So an angle of depression is the angle formed by the horizontal line. So basically every time we're looking at this, you're always drawing this horizontal line. And then the angle of depression goes down from that horizon versus the angle of elevation goes up from that horizon. So the angle of depression, by definition, is the angle formed by a horizontal line and a line sight to a point below the horizontal line, looking down, versus an angle of elevation is more like looking up. It's the angle formed by a horizontal line and a line of sight to a point above the horizontal line. So this next piece here, since horizontal lines are parallel, angle 1 and angle 2 by the alternate interior angles theorem are in fact congruent. Therefore, the angle of elevation from one point is congruent to the angle of depression from the other point. So again, alternate interior angles, meaning if these were our parallel lines and this is our transversal, this angle and this angle are going to be the same. So that will help us when we're drawing our diagrams, because we'll be able to draw a right triangle with the right angle up above or with the right angle on the base there. Alright, so we're going to go ahead and classify each of these. Again, angle of depression is looking at the horizon but then down. So the only ones that are going across at the horizon and then down are angle 1 and angle 2. Angle 3. And then if we're going from the angle of the horizon parallel line up, that's your angle of elevation. So angle of elevation is angle 2 and angle 4. So we're going to try some examples here. So we're going to find the distance by using the angle of, in this case they said elevation. So the Space Needle casts a 67-meter shadow, and if the angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees, how tall is the Space Needle? So we're going to have this horizontal line, right? And then it says the angle of elevation, so we're going up from that horizontal line. And we're actually going to be calling this the shadow of the Space Needle. The Space Needle is in, Seattle? Okay, anyway. So here's your Space Needle. It makes a 90-degree triangle with the ground there. And it's telling us that this degree measure is 70. We also know that that shadow is 67 meters. And so we need to know how tall is the Space Needle. So we're looking for this value. Alright, so we need to go ahead and set up a proportion to solve this. So let's see, we have our degree here. We have this side over here, which is the opposite. And we have this side over here, which is the adjacent to that given angle. And so that means that we would be able to solve the SOHCAHTOA, the trig that has opposite and adjacent, which is tangent. And so we're going to say tangent of 70 is going to equal our opposite, which we don't know, over our adjacent, which is 67. So how do we solve this one? Again, we're not finding any angles, so we don't need inverse, but we're going to want to multiply across, so 67 times tangent of 70, and then x times 1, which of course is just going to be x. So making sure that you are in degree mode, we'll take tangent of 70 and multiply by 67. And our answer to the nearest meter is going to be 184. It's technically 0.08, but 184 meters. Alright, and then our last one here talks about a lighthouse. Apparently a lighthouse is 69 feet above the water. So it must be on some sort of cliff, I'm guessing. So here's our little lighthouse. Looks like a person. Let's see. So the person is 69 feet above the surface of the water. So here's our water. He sights two boats. So we've got our horizon line, and the angle of depression to the nearest boat is 48 degrees. And then the angle of depression to the further boat is 22 degrees. So we'll just draw our little boats here. Alright, so we got kind of a lot going on here, so I'm going to redraw my two triangles. So let's see, this blue triangle has 48 degrees right here, and then based on the diagram we've got 69 feet here, because if this is 69 feet then so is this, even though it's on the opposite side, and then ultimately so will this, and then we're trying to find this piece so we can subtract it with the other triangle, which is a right triangle that has 22 degrees here, and then just as the other one is 69 feet here, and then this x value here. Alright, so both are going to use the same trig here because both have the opposite side and then wanting to find the adjacent side, just like over here, adjacent to this angle and opposite to this angle. So to solve this first one, adjacent and opposite, as we saw in the previous one, is tangent. So we're going to solve tangent of 45 equals 69 over x. And then for the next one, we're going to solve tangent of 22. And that's going to equal 69 over x, opposite over adjacent. But to solve, remember we're making a proportion. So we're going to cross multiply 69 times 1, and then tangent of 45 times x. And the same happens in the second one. We're going to cross multiply 69 times 1, and now tangent of 22 times x. So what happens in the first one here is that we end up with 69 times 1, so 69 is going to equal tangent of 45 times x. And so to solve, we want to divide by tangent of 45. So to get our x, we do tangent of 45 divided into 69, and we'll end up with an x value of 69, which makes it seem like it's not the right answer, but that's because tangent of 45 is actually 1. So that's our first one, but for the next one, again, we'll get 69 from 69 times 1, but then that's going to equal tangent of 22 times x, which again, we'll divide by the tangent, because it's just a digit. So 69 divided by tangent of 22 in degree mode leaves us with an x of 170.78. It says round to the nearest foot, so we may as well just round that to 171. And so in order to find the distance between them, we take 171 minus 69, and we get 102, what were we saying, feet? Yep. Feet between those two boats. Alright, so that is our angle of elevation and depression. So basically in your assignment, you're going to set up some right triangles and then use your trig to solve.